So an official welcome. It's lovely to see you. My name is Liz Woodham, and I'm a member of the NRICH team. We're based in Cambridge in the UK. And with me this afternoon is Charlie. Hi, Charlie.
Hello.
And Ems as well, who's the director of NRICH. We're very grateful to Trinity College here in Cambridge, who have provided us with funding so that you don't have to pay to attend these webinars, and we very much appreciate it. The recording from this session will go up on the NRICH site, and we'll let you know the URL at the end, so you could share it should you wish. We hope that you will join in with some mathematics with us this afternoon, and at various points we'll invite you to contribute using the chat facility. And obviously, well, I say obviously, we'd like you, please, to feel very welcome to contribute, partially formed ideas. Please do not feel that you have to have everything polished before you contribute on the chat. Okay, so I think it's time to get going properly. I'm going to share my screen, just as a sort of by way of introduction. I'm hoping that you will shortly be able to see the NRICH homepage. Charlie, could you just give me a thumbs up or a nod? Are you seeing that? Fab. So this is the NRICH homepage, and we hope you might have noticed that our session this afternoon is going to focus on resilience. So we have on the NRICH site collections of resources which we hope help to develop students' mathematical habits of mind. And before we get going on some mathematics, I just want to point you in the direction of those so that you know where to go for follow-up resources. I'm going to pretend, first of all, that I'm a primary teacher. I'm going to click on the primary teacher homepage, but this is exactly analogous for secondary teachers. You do the same thing, secondary teachers. And in this middle box, you can see we've got a button which says Mathematical Habits of Mind. So what we've done here is we've collected our resources together into discrete packages. And what we're hoping that students, when faced with a new mathematical task, one that they've not seen before, they would demonstrate these habits of mind. We've got 4 here: being curious, being collaborative, being resourceful, and being resilient. And here today, we're going to focus on being resilient. So if after today's session, you are keen to explore with your students some further activities, please do explore the Being Resilient collections at both primary and secondary. So I think, Charlie, we should get going on a task. I'm going to hand over to you, Charlie, if that's all right, to lead us into it.
Thank you. Yes. So I think the first thing I'm going to do is share my screen and give everybody a problem to work on. So here we go. Some of you may know this problem already. It's called the number jumbler. Can you see that, Liz? Okay, so you'll need paper and pencil possibly, though you might be able to do this in your head. And the problem starts like this. Let me see if I can just enlarge it just a little bit and where they can still fit on the screen. Yes. Okay. Good. Okay, so I'd like everybody to have a go at this problem. So it starts by asking you to choose a 2-digit number. So 24, 47, 91, 16, any 2-digit number. And then add together both digits. So if you had 42, for example, you add the 4 and the 2. And then once you've done the addition, you need to subtract the total from your original number. So if I had 42, I'd subtract 4 plus 2 is 6. I'd subtract 6 from the 42. Okay, so that's all the arithmetic you need to do. I'm hoping you got an answer which appears on that grid, because all your answers should be bigger than 0 and smaller than 99. So the next thing I'd like you to do is find your answer on the grid, and then take a look at the symbol that's just to the right of your answer. So if your answer was 13, you'd see a bicycle. I think if your answer is 44, you might see a cat. So I'd like you to take a look at the symbol, and it's about to go away. So I need you to memorize what that symbol is, please, because all the symbols are about to be jumbled up. Hence the problem's called number jumbler. And let's see what happens. Hope you're all ready. So here we go. Jumble up all the symbols. I was looking at a number that had the star symbol. But is that what happened to you? Can you write down in the chat what symbol you were looking at? I'm just curious. Oh, wow. Everybody so far has got the star. One person didn't, but everybody, bar one perhaps, looks to have got a star. So I might not have explained the rules carefully enough to at least one person. So that's really surprising. I'm going to stop sharing. So my question to you is, how on earth did that happen? And I'd like you to imagine that that is a challenge that I'm setting you. Or if you prefer, imagine setting that challenge to your students. What can I do? What would you like me to do as your teacher? Or what do you think your students might like you to do? What kind of support might you offer if you want them to have a go at this problem and not give up too soon? Some students might be thinking, well, I don't have a clue what happened there. I'm going to wait for the teacher to explain it all to me. If I sit quietly here for long enough, eventually the teacher always tells me what to do. If we want to avoid that situation, if we want the students to think about this problem and solve it, what kind of, let's use the word scaffolding, might we offer so that the students remain engaged on this problem, or you remain engaged in this problem for long enough that you have a go at it? So again, in the chat, could you suggest some things that I could do that would help you, or that you might want to do that would help your students? Great. There is a lot of overlap, inevitably, between what a lot of people are saying. A lot of people are asking to try the example again, or to try give the chance to do a few more examples. Some people are talking about gathering together the solutions so that we've got some data. So if we were in a classroom, put some of the answers on the board, so it becomes a collective enterprise rather than something we do individually. Some people are talking about looking for patterns in the answers, then exploring the chart. And then if there is a pattern, somebody's talked about proof. How can we work out what's going on? And already some people are making some conjectures in the chat. We really like conjectures at NRICH. But what's particularly nice about the way that Ben has been posting is that he's been putting, and he's not the only one, Janine has also, several people have been putting things, statements with a question mark. So we are emphasizing that at this stage in the conversation, we're not quite sure. We've only done one example. We want to test out ideas. So I'm going to share my screen again, and I will do what you've asked for. So we're going to try again. So what we'll do is we'll try again, and then I'm going to record some of the results, and then we can have a look at what you got. So choose a 2-digit number. It can be the same as last time, or it can be different. I don't mind. You choose. Add together the digits, just like you did last time. So again, if your 2-digit number was 42, add the 4 and the 2, and then when you've got the total, take that away from your original number, and then find your answer in the chart and try to memorize the symbol beside it. And I'm about to jumble them up. Hope I've given you enough time. Here we go. And there seems to be a fairly happy face of, I don't know, I don't know whether it's supposed to look like a grandma or not. I don't know. Anyway, I'm assuming that most people will also have had that symbol. So could you now, as if we were in the classroom, write down what your total was? And what I'm going to do is I'm going to share the bit of paper that I'm writing on. Liz, can you read out the numbers that people got from their calculations, please?
I shall try to keep up. Yes, I can. So 45, 36, 81, 63, 27, 18, 42, 54. Have I said that? No.
Doesn't matter if you repeat yourself.
Okay. 72 again. Oh, somebody says not 42.
I'm glad.
Yeah.
72, you said.
Yeah. We've also got an 88. $27 again.
So 27 again, the 2 that went for 27.
Yeah, we've got a few we've got a few of those that have been said more than once. Okay.
I'm surprised by the 88. So I'd quite like whoever got 88 to tell us how they got 88, if possible. I'm just trying to think. I must have started with something in the
Oh,
nine.
oh, typo, 81.
Okay. Okay, so there are two 81s there.
Don't worry, Ben, don't worry.
Okay. Okay, so this could go on the board as an example. And some people were talking about looking for patterns. And so one way of looking for patterns might be to list these in order. So let's do that. Let's start with the smallest number that's been read out, 18, and then 27 was read out, and then 36 and 45, and then 54, and 63, and 72, and 81. And it might be a lot easier for us to to notice patterns if we write the numbers in order. Okay, so perhaps now in the chat, in a way, sort of trying to model what might happen in the classroom, perhaps everyone would like to write down anything they notice about the solutions that we've had.
I guess, Charlie, it might be worth saying, and I'm sorry if I'm butting in, but I guess in the classroom situation, what you might do now is invite students to talk to each other first, mightn't you, before they offer to the whole group. And of course, we can't really do that easily on this platform, but yeah.
No, that's really useful to have mentioned that, Liz. You're welcome to interrupt me at any stage. I love the realization. So I think something called Karen wrote. I don't want to give away everything she wrote, but she wrote, and one of the 4 habits of mind, Liz, that you mentioned was curiosity. And so if there is a sense of surprise, it might well lead to students being curious about, why does this work? Oh, I wasn't expecting that to happen. And that might be the hook that then prompts the rest of the mathematical thinking that follows on.
It's an interesting point, Charlie, about 90. I don't know whether you were going to leave that hanging or.
Okay, so somebody called David says no one can get 90, but he's also put a question mark.
Mm-hmm.
And I suppose we can, the only way you could get 90 from a subtraction is if you started with a number that's bigger than 90. But if you start with a number that's bigger than 90, say 92, your digits add up to 11, you take 11 from 92, you get 81. If you start with 94, your digits add up to 13. If you take 13 from 91, you're always going to take at least 9 because you've got 9 in your tens digit plus something else. So you're going to end up with less than 90. And so you can, even though all the numbers that I've got written down here and the 9 times table, it is impossible to get 90 because none of the subtractions. Could we have got 9? If we'd started with 12, for example, our digits add up to 3. And if you take 3 away from 12, so I think we could have got, I mean, nobody got 9 because everyone wanted to practice their arithmetic with big numbers, but some students might have got, okay, so it looks like we're all getting, so we might want to go back to the interactivity and have a look and just see why this is happening. A lot of people have noticed that on the first round, all the multiples of 9 were stars. On the second 1, the multiples of 9 were a different symbol. I don't know whether it's worth sharing that to have a look at, but I just want to confirm that that is the case every time you do it. I mean, of course, sometimes I imagine it's randomly produced and you might get a repeat. And then we might go on to proving and talking about how you do this. I don't want to get too bogged down in this actual problem. We wanted to use it, so I'm going to stop sharing this perhaps. And Liz, maybe you and I can talk a little bit about what people wrote in the chat and what we've picked up on and how this might help develop resilient learners in the classroom. So yeah. If I kick off and then you chip in. So one of the things was that we didn't expect them to work out the answer immediately.
Yes.
That we give students an opportunity to try several examples. Mm-hmm. The answer is not immediately obvious, and in maths you need to work on it for a while before starting to make conjectures and so on. And so speed is not of the essence here. Actually, it's having, it's not pace, it's space. It's space to think, space to talk to each other, space to jot down ideas, think, pair, share kind of situation. Absolutely. So I think that, it seems to me, is much more likely to lead to encourage students to hang on in there.
That's right.
Rather than give up very quickly.
That's right. Yeah, and I think linked with that, you've already mentioned to some extent this idea that this is a collaborative enterprise, that, you know, for example, when we're not expecting students to work quickly on their own, we're expecting the thinking, but actually, as we mentioned the think, pair, share, you gathered everybody's responses, so it became us as a community working together. I think that's important too. I think so you're not worried. Perhaps that takes away the fear we mentioned earlier about possibly exposing yourself to being wrong in front of everybody. If you have those times to chat to other people and you're gathering results, that feels a safer environment.
John Mason talks about convince yourself, convince a friend, convince the enemy, though he might use a different word to enemy these days. But
skeptic, maybe.
The way that I interpret that is that it's a lot safer to talk to the whole class once you've talked to your neighbour, and it's a lot easier to talk to your neighbour if you've been given a bit of time to think about the problem rather than expected to. Okay, so the other thing we talked about was that some people wrote statements with a question mark.
Yes.
So I think conjecturing and having a classroom where students are encouraged to conjecture. So it's not just the students who think they know the answer who are the ones to speak. Everybody speaks. And you might speak because you're not sure, because you want, this is something useful to talk about. Well, it could be this, but I think it could be that, and I need some help. Dylan William did an interesting exercise with a school in Hertfordshire many years ago that was shown on television, where he encouraged a school to give up the hands up policy and instead encouraged the teachers to choose at random who they were going to ask the questions of. So the teachers would write the name of all the students in each class on lollipop sticks, put the lollipop sticks in a tin or a jar, and then randomly pick up. And the idea was that gave the teachers a much better idea of what children were thinking. It wasn't just the children who were certain who did the speaking. And it meant that, in essence, we're accepting that not everybody will know the answer, and it's okay not to be sure, and it's okay, and it's important to be able to articulate that, and there is no shame in it, and there is a chance for other people to collaborate and help and so on. So having a conjecturing atmosphere in the classroom seems to be really important, rather than a class where only the people who are sure do the talking.
Yeah.
So I'm going to add conjecturing to our list.
Yeah. I think, Charlie, what we're saying really is that if we would like students to become more resilient, we as practitioners, we as teachers, we need to try to create an atmosphere in the classroom which supports exactly what we've just been talking about, and that there are lots of links here with growth mindset, aren't there? And if I'm faced with that number jumbler task, my view is that I'm no good at maths, and there's a particular kind of person who has a maths brain, then why would I bother being resilient? Why, there is no point. I just switch off. However, if I'm in an environment where, I believe that it's worthwhile working on maths, I believe I can get better at maths, then that's a complete shift, isn't it? And I approach mathematical tasks in different ways, and part of the teacher's job is to help students understand that's what they as the teacher are valuing, the working at mathematics. I think.
Yes, so Carol Dweck talked about students doing better when their teachers have got a growth mindset rather than a fixed mindset, and she and Joe Bowler talk about a teacher who, when students say, I can't do this, they say, no, you've got to rephrase this and add the word yet at the end of the sentence. And a classroom where students are saying, I can't do this yet, and the teacher reacts to students by saying, no, you can't do this yet, is completely different to, I can't do this. Yeah. I can't do this is like, I'm giving up. Yeah. I'm putting my pen down.
That's right. That's right.
There's one other thing I think I wanted to mention. Esther Dyson apparently said, always make new mistakes. And I think what she was talking about was two important things. One is when you're learning and when you're being challenged, when you're trying to do new things and you're pushing yourself at the limits of what you can do, you're bound to make mistakes. I think it was Matthew Said who wrote about, in a book called Bounce, he talked about, to be international level ice skater, you've got to be prepared to fall 1,000 times and get up again. That if you don't fall often, then chances are you're not really challenging yourself, and you're never going to be able to do the kind of pirouettes that are going to afford you lots of points. And inevitably, when you start doing these pirouettes, you're going to fall. So you're going to have to be prepared to make mistakes. But also this idea that you've got to make new mistakes. So if you're going to make progress, don't keep making the same old mistake that you made before, and don't make the mistake that other people have made. So do try new things, but learn from your mistakes and other people's mistakes. So I really like that. And it sort of also reminds me of why WD-40 is called WD-40. Yes. I don't know whether everybody knows, WD stands for water displacement, and WD1 wasn't really good, so it was improved into WD2, and the formula for that wasn't great, so they carried on testing new ideas, WD3, WD4. Eventually, WD38 presumably was pretty good, but still not quite good enough. And they didn't give up. They went up to WD40, at which stage presumably they were happy. So I think that's yet again and yet something else that is important. And perhaps we don't emphasize sufficiently that making mistakes is inevitable, and that we learn from our mistakes. So I'd quite like to add that to our list. learning from mistakes. I've been writing these down, so I'm thinking I might just share what I've written in case it's
great.
useful to everybody.
Yeah.
And you can see what I've written. Learning from mistakes is inevitable, and I'm going to just add Esther Dyson's quote that I like.
Yeah.
And then if you can see everything that I've written, Liz, or
Yes.
anybody else in the chat, and there's anything that is glaringly missing from here, always make new mistakes.
Yeah. Yes. Thank you to those of you who are chipping in with particular comments on the chat. Although we may not be, pulling them all out individually, we are reading them. So thank you. So I guess, Charlie, what at NRICH, what we are hoping to offer are ways that we're offering interesting problems. So we're offering students opportunities to get stuck, because otherwise they're not learning. But we're not talking about floundering with no support. We're trying to think about how we might scaffold students, but crucially, we still want the students themselves to be doing the important thinking, don't we? And so shall we move on to another task? So one of the ways at NRICH that we thought we could potentially offer students this scaffold, but still let them do the work, is the way we've kind of thought about it is by offering them sort of a route, or Charlie calls it shining a spotlight. I think, Charlie, is that right? Would you like? Have I got that right?
Shining a torch.
Shining a torch. Okay. So we're offering a potential route through a problem, but we're not doing the mathematical thinking for students. So let's have a quick look at a task, which is an example of this on NRICH. I'm going to share my screen. Now, this might be familiar to some of you. It doesn't matter if it is, because we can still join in. Can you see the math doku, Charlie?
I can, and I imagine you could make it a bit larger and it would still fit on your screen.
Yeah, I will do. Thank you. Is that okay?
Yes.
Okay, try one more. Ooh, there we go.
That's even better.
Great. So we've got a whole series of math dokus on NRICH. What we're trying to do here, we've chosen a 4x4 math doku to give you an idea of what we mean in this context. What we're trying to do is we're trying to fill the grid so that each row and each column contains the numbers 1, 2, 3, and 4 exactly once each. We're given some clues, as you can see. We've got some bold lines around particular cells. We're going to call those cages. And we're given an operational clue. So, for example, the top right here, there are two cells bound together. In the top left of those, it says divide 2, 2 divide. So that means that one of those divided by the other is 2. Now we've got one here, which is given away for free, if you like. This is telling us that this cell is 1. So I'm going to click there and I'm going to pop that in. Now, the reason that we'd like to show you this math doku is because built into the interactivity is the kind of scaffolding that we're talking about. So Charlie, we've got the 1 in, but I wonder where we might go next.
Okay. Yeah. So I happen to know I've done this one before. So in a way, I don't need the help.
Yeah.
And I may want to do this and enjoy being able to do it without any help.
Yes.
But not everybody will be in my situation. And this, I mean, you haven't mentioned it, I don't think, Liz, but this is a difficulty level 3 problem.
I didn't mention it, thank you. Yeah.
So students might have had to go difficulty level 1 and coasted through that. But we also want everybody to sort of have a go at difficulty level 3. And of course, there will be some people who can do it without any help. But there were some students who might be might find this is too difficult, but we still want them to have a go. So as Liz said, there is an opportunity of asking for help. So if you click on that, Liz.
I will do.
Thank you. It says that there's enough information. The message there is, it's sort of shining a torch at that second cell in the first column. And it's saying, oh, I can do that. Now, again, I know the problems, I know what should go there, but that might still not be sufficiently helpful to me. And so I'd be interested in you clicking on the green square, which asks for the hint. Which other numbers must be in that row, it's saying. Okay, so again, it's forcing me to think and look at the row, and I'd say, oh, to the right of that cell, there are 3 cells and the product is 8. And I can figure out that if I've got to use 1, 2, 3, and 4, and 8 is not a multiple of 3, I'm going to have to use 1, 2, and 4. I don't know in what order, but that then tells me that that cell that's highlighted must have a 3.
Must be a 3. Absolutely.
So, as you were saying, Liz, what it's doing is it's offering a bit of support, but it's still requiring me to do the thinking. Can we assume that I'm stuck again?
Yeah, help again.
Green,
okay, so now this one here.
Okay, so now I've got 3 cells, an L shape that comes to 18. And I think, oh goodness, well, let's assume I've got no idea.
Should we try a hint?
Let's have a hint. Which other numbers must be in that row? Ah, okay. Oh. So to the left of the 1, I need 2 cells that multiplied together with the 3 are going to give me 24. Okay. So I know that 3 times 8 is 24. So that tells me it must be 2 and 4. And therefore, there's only one possible other number. I think they could have given me a different hint, Liz. They might have also said what 3 numbers need to go in 18 times, because 18 is 9 times 2.
Yes.
And the only way to get 9 is going to be 3 times 3. So I think I'm going to need 2 3s and a 2.
Absolutely.
And I could not have 2 3s on the same row. So anyway, the important thing is there are hints if you need them, but you're not forced to read the hint. And before you're given the hint, you're even told, have a look at that square cell and see. And that feels a really lovely way of supporting students, but not doing their thinking.
Exactly. Yes. Thank you, Charlie. Would you like to show another example of that, or should we? Yep.
I'll show very quickly the product Sudoku.
Yes.
But this time I've got a photocopy of it. So I'm going to stick that on. I hope you can see that.
Yes, can. Yeah.
I'm going to just go down a bit. Okay, so it's normal Sudoku rules. And I'm going to see if I can focus the far left a bit better.
Yeah, I think you might be safe to perhaps read out any number that you do refer to, Charlie, please, because we can just about read it.
Okay, so here the rules are the normal Sudoku, except you're given some numbers. So this 405 there, for example, is the product of all the adjacent cells. So this one, that one, that one. So cell above, cell below, cell to the left, cell to the right, multiply to give 405. Goodness knows what goes in those cells. That's not a good place to start. Here, for the 30, I don't have a cell above, so it's the cell to the left, to the right, and below. The product is 30. So it'll be 5 times something. And the something could be 1 times 6 or 2 times 3, and we don't know. Or we know for sure there's going to be a 5 there, but that's all we know. That's not a good place to start. I could imagine, I mean, goodness, look at this, 2,835. Yes, well, so you can imagine if you're not a resilient problem solver thinking, oh, this is too difficult for me, I'm going to give up. So what we've done is, in the spirit of shining a torch, in the help, we've suggested a route through the problem, saying there's enough information on that sheet to do those two cells. So 1 and 2 mean that's the first cell and that's the second cell that you could do if you choose to go along the same journey that I went. And once you've done 1 and 2, you can do 3 and 4. And once you've done 3 and 4, you can do 5, 6, and 7. I'm going to stop there and we're going to have a go doing it so that the student still has to do the thinking, but at least is being told where to look. Okay, so here we go. Cells 1 and 2 are these two here. This number here says 20. So these two cells, the one to the right and below, have a product of 20. I'm not allowed to use 1 and 20 because 20 is too large. I'm not allowed to use 2 and 10. I've got to use 4 and 5. This number here is 96, which is a multiple of 4, but not a multiple of 5. So I must have to put the 4 here and the 5 here. So I've done cells 1 and 2 using the help that I've been given. And then I'm told I can now do cells 3 and 4, which are these two at the bottom here. And why can I do that? Well, because that says 4 there. So the product of these two must be 4. I'm not allowed to use 2 2s because of Sudoku rules. So I've got to use 1 and 4. And now, because I've got a 4 there, I know I can't use a 4 there. So therefore, that must be 1 and that must be on 4. And so on. Now, I'll stop there. But the important thing is, students can choose to use this grid if they're completely stuck and carry on thinking and not give up. The first time you see a grid like this, you can be slightly overwhelmed by it. And of course, working with a neighbor would be a great way of easing the pain. But also, there'll be some students say, no, don't give me the hint. I want to have a go. But if I'm really, really stuck, I might look at this, make a start, and then stop looking at that and say, okay, I get the idea now. Once I've done the first 2, I'll do the rest without the help. But if I really get stuck, what we want is for students not to give up. And so I think what you showed with the math dokus and with this product Sudoku is one attempt at helping students. Now, we hope we've got time for 2 other ways in which to talk about 2 other ways. And one is to suggest to students that there are different ways of approaching a problem. So I'm going to stop sharing, Liz, and let you share.
Thanks, Charlie. Yes. So as Charlie says, we've had a look at a way where you can shine a torch. But let's look now at offering students perhaps different starting points. So we're starting a method. Here, this is a task called different deductions. Now, actually, this is the primary version of the task. We also have a secondary version, which is called What's It Worth, in case you'd like to have a look at that. The mathematics is exactly the same, but the supporting material is very slightly different. So take a look at this grid. Let me give you a moment to have a little look. We have got some symbols on the grid. You'll notice that there are also some numbers at the end of each row and at the foot of each column. So these denote the total of the symbols. So each symbol has got a value. And so this 28 is indicating that the 4 symbols in the top row have a total of 28. Our challenge is to work out what total is represented by the question mark. Now, I'm going to offer you 30 seconds to have a think, and I'm deliberately not giving you enough time. I would like you to feel stuck. So just have a little look and I'll stop talking. So if we scroll down this page, what we're going to do is we're going to draw your attention to some particular parts of the grid. So if I click here, image 1, if I'm going to show you image 1, the question now is, what can you deduce from this image? Have a little think. Would you like to post in the chat anything you can deduce? Okay, nice. So we've got some contributions. Thank you to those of you who've put some contributions in. So somebody's mentioned that a square plus a triangle is 14. Okay. Right, so I guess from that top row, we know that 2 squares and 2 triangles together make 28. So half of that would be 14, and that would be 1 square and 1 triangle. Absolutely agree. So if we know that, I wonder how that might help us. What has somebody else has said? The difference between the triangle and the square is an important discussion point. Thank you, Philippa. So we've been told that 2 triangles and 2 squares add to 28. When we've got 3 squares in a triangle, we've got 30. So therefore we know that a square is 2 more than a triangle, which some of you have pointed out. Let me look at some of the other comments coming in. The square is, okay, so, oh gosh. 4 squares equal 32, somebody's saying. Square is 8. Okay. So if we know that the square is 2 more than the triangle, have I got the right way in? Square is 2 more than the triangle. We know together they add up to 14. So we've got 6 and 8, is that correct? 30 minus 14 is 16, so the square is 8. Charlie, have you got any thoughts on that?
Well, the way that I might do it, Liz, is look at the column that you've highlighted.
30, yeah.
And I know that the square and the triangle at the bottom, you've said add up to 14.
14.
The
and
whole
then
thing
we've
adds up
got
to 30.
left. Yeah.
So we've got 16 left.
16 left, which is what somebody has posted here. Brilliant.
Yeah. So the 2 squares must add up to 16. So each square must be equal to 8.
8.
And if you go down to image 2,
yeah,
I think you can use very similar reasoning to that, where you say the square and the triangle is 14. And now if you look at the far right column, the square and the triangle is 14. The whole column
is 22.
And so the 2 circles are worth 8. And
then you can
carry on. And I think you can even do that with a third image, but it's slightly. So again, here, you know the square and the triangle is 14. The 2 bottom rows, the whole lot is 38. It's got a square and a triangle.
Yep.
So let's get rid of that. And 38 minus 14 gives you 24. And so the 6 circles that are left must be. So what I like about this, Liz, is that if students are stuck, we're again saying, hey, look, there are different, because it's a bit like the product Sudoku. It's just too overwhelming. There's just too much information. And you're saying, oh, look at this and see whether you can, and if this diagram isn't useful, look at this one.
Yeah.
And if that's not useful, and somebody's posted about, well, what do you do when students get the answer very quickly? I mean, this is a nice problem for that, because you can say to students, okay, can you solve it in a different way?
Yes.
And you look at images 1, 2, 3. I mean, there are 6, and we don't have time to look at all 6.
There are 6.
But is there a way? I mean, if you just click on image 6,
Yep.
I mean, this is brilliant. I mean, what on earth are people thinking there? And I don't know whether to give away the answer.
No, don't give it away. Don't give it away.
Okay, I would. But so some of our highest attainers might think, oh, what on earth is going there?
What's that?
So hopefully, if a problem can be solved in more than one way, we want students to be not only resilient, but also resourceful, because they can come at it in different ways. And we will hopefully do a webinar on some of the other habits of mind that Liz talked about.
Yeah.
Being collaborative, being curious, being resourceful. But here we're just concentrating on being resilient.
Yeah.
And so we hope that offering different strategies like this just draws attention to the students that, oh, if you don't know how to go about this problem, here we're nudging you.
Yeah.
We're providing a little bit of scaffolding, but you still have to do the thinking.
There's still lots of thinking to be done.
Okay.
I wonder, Charlie, whether we should take a look. So we've looked at shining a light on a route. We've looked at offering some different ways in, some different methods in. Shall we have a look at what we like think of as the sort of the third way that we might, because I realise we've only got 5 minutes left. And the third thing that we find can often help is offering students proof sorters. Charlie, would you like to share an example of that with us all? I'll stop sharing.
So, like Liz says, let me find. Okay. So we thought of 3 ways in which at NRICH we try and help students hang on in there, because often students are working on their own. Well, yes, sometimes students are working on their own and they don't have somebody to talk to. Sometimes they get stuck. Historically, some people thought that NRICH was only suitable for really high attaining students, and we've been trying to challenge that view by making our problems slightly more accessible. Now, we want to make them more accessible, but we still want the students to do the thinking. And so, as Liz said, shining a torch, saying, oh, I think you can do this, or offering different strategies. The last one that we want to do is say, like a problem with kite in a square, is say, well, somebody had a go at this, but all the explanations jumbled up. Whether it's an explanation of how to solve this problem or a proof, we use proof sorters as a generic term to describe a jumbled up affair that needs sorting out. So here, the question is, what fraction of the total area is shaded? And we're told that ABCD is a square, and we're told that M is in the middle of the line AB. That's all we're told. And like in the other examples, we've got 3 different ways of approaching this. Coordinates approach is the easiest one, so that's the one that I'm going to go to. And the proof sorter is going to be based on this model, assuming that we use a coordinate grid and assume that the coordinates of the square are, the vertices are 0, 0, 1, 0, 1, 1, and 0, 1. So I'm going to do this fairly quickly and hope I can get this right first time. I got it right second time earlier when I had a go at this. So the nice thing is you can move these cards around, and we also have downloadable printable sheets. So if your students can't work online, they can cut them up and work them. Consider a unit square drawn on a coordinate grid is going to be my first statement. And then I might say the line joining 0, 0 to 1, 1 is y equals x, and the line joining 0, 0 to a half 1, that was the M along the middle of the top of the square. And the line, the diagonal joining 0, 1 to 1, 0, the one that went across is at 1 minus x. And this proof is going to have a go at working out the area of the kite. We know what the area of the triangle, of the square is, because we've just given it lengths of 1. So if we can work out the area of the kite, we can work out what fraction of the total area it is. And we're going to do that by working out the area of half of it, because half of it is a triangle. And we're going to think of this dotted line here as being the base of the triangle, and the distance between AB and the base as being the height. So here we go. I think the next thing to do is think about the point AB, which is where the lines y equals 2x and y equals 1 minus x meet. And that must be a third, 2/3, because a 2/3 is twice a third. And if I take 2/3, if I take 1/3 away from 1, I get 2/3. So that tells me that A equals a third, and I can now think about the shaded area is made up of the two congruent triangles that I was talking about, and I know what the coordinates are. I know now that the perpendicular height of the triangle is going to be a half minus a third. So I know that the height is a 6th, and I know that the area of the triangle is now going to be half base times height. And there it should line y equals 2x at 0.80. Oh, sorry, I should have put this earlier, I think. Line joining, so A, the point AB is, I should have. So the area of the triangle is 1/24th, so the area of the shaded would be double that. So it's a 12th, and we submit and we get it right. Thank goodness for that. Apologies for, okay. So the idea here is students might have found it difficult to solve this problem on their own. We're not giving them the answer. They still have to do quite a lot of thinking, like I did just now, but it's much more likely that they're going to get to the answer if we offer them that kind of support. Sorry, that took a bit longer than we'd imagined. Over to you, Liz.
Thank you, Charlie. Thank you. And we've sort of galloped to the end of our session. Thank you so much for listening, for participating. We just wanted to finish up by reminding you, let me, oh, Charlie, you look like you're going to say something.
Yeah, I do want to say something. Sorry, Liz.
No.
I mean, partly because we've rushed through this. There is important, we do have pages, both on the primary side and the secondary side, called What We Think and Why We Think It. Mm-hmm. Mm-hmm. And I think we've got links there to Carol Dweck's work,
yes,
who wrote a book called Mindset, possibly to her TED talk, yeah, to Joe Bowler's work, who also talks about group work and working collaboratively, starting with challenges. She talks about saying, can't do this yet. Matthew Said hasn't written a book in the context of maths, but his book Bounce is all about bouncing from experiences where, from some sort of failure. A primary school, a parent of a primary school child told me the other day that when their village or their town had some Olympic medalists after the 2012 Olympics, and they were invited to the primary school of his children, and the head teacher didn't ask them to talk about what it was like to win. He asked the two medalists to talk about the times that they had failed and how they had responded. Because obviously they hadn't always got into team, they hadn't always won, it hadn't been plain sailing, and he wanted the children in the school to know, to learn about what it's like. And I was telling you the other day, earlier, Liz, Andy Murray won some semi-final the other day and survived 5 match points. And it's like, this man just does not give up. We have so much to learn from people like that. So it's not just a maths context that we can learn from. So those messages. So if you want to know more about this, go and have a look at what it's worth. What we think and why we think it. Enough from me, Liz, sorry.
Well, I'm not going to add very much more, just to say thank you very much. We hope we've given you some ideas about how you can support your students to become more resilient, how you can encourage them to do the thinking without you doing the thinking for them. Please, if you have chance, we would love you to give us your feedback on our event this afternoon. I'll pop the link to the form in to the chat again there. It's really important that we try and get these events as good as we can. So please do offer your thoughts. The recording of today's webinar will go onto the NRICH website, and you'll get a link in the email follow-up. I'm sorry that we've run over time.
Somebody's just posted they couldn't find the crib sheet for product Sudoku.
Okay.
It's in the getting started. So whenever you look at the problem, on the left-hand menu, there's a link to getting started, and there's always something there. And the crib sheet that I showed for product Sudoku is there. Yes,
exactly. Okay. Thank you all very much for participating. We look forward to seeing you at a future event.
Sorry to overrun.
Bye.
Bye.